Good evening, everyone, and welcome back to solving three-dimensional problems using the sine and cosine rule, as well as Pythagorean theorem. So we're going here to find missing sides or missing angles. So here we are finding missing sides or missing angles, and that's our objective of the video today. But it's in 3D objects such as the one we see here in this diagram. So in the diagram, A, B, and O are points in the horizontal plane. A, O, B. That's the horizontal plane, which means the face that is sitting on the floor. And P is vertically above O. So P is vertically above O, which means PO, line PO makes a perpendicular, makes a 90-degree angle with OA, where OP is H. So they named this as an unknown, OP as H. M, and it means in meter, the measurement units in meter. A is due of west of O, B is due south of O, AB, as you can see here, is 60 meters. The angle of elevation of P from A is 25 degrees, and the angle of elevation of P from B is 33 degrees. First thing, we need to find AO in terms of H. So it means we're going to find AO not as a number, but we're going to find it in terms of H. Accordingly, we're going to choose triangle POA or triangle AOP. So we can name it POA or AOP. And we're going to draw a little sketch for it. Now, the given angle, which is 25 degrees. According to this given angle, H is the opposite side to this given angle or to this known angle. So, what is OA? OA is the adjacent side, and that's what we are trying to find. PA, because it is right across the 90-degree angle, so it is my hypotenuse. Now, in order to write or to find AO, we need to use the tan rule, the tan of 25. So tan of 25 degrees is equal to opposite over adjacent. Let me remind you a little bit. Sine of 25 is opposite over hypotenuse. Cosine of 25 is equal to adjacent over hypotenuse. Tan of 25 is equal to opposite over adjacent, and that's what we need. Let's substitute in this rule. What is the opposite? It's H. What is the adjacent? It's AO. So when we substitute, tan of 25 is equal to H over AO. Now, we are solving for AO. Get rid of the AO is the denominator. So we're going to get rid of the denominator by multiplying all by AO. The result will be AO times tan of 25 is equal to H. The subject here is H, but I need AO as my subject. And tan of 25, if we insert this in the calculator, it's going to be a number. So we're getting rid of tan of 25 by dividing all by tan of 25. Once again, AO, the unknown, times tan of 25. And we solve for AO by applying opposite operations. So since the operation here is times tan of 25, then to get rid of tan of 25, we're going to divide all by tan of 25. Accordingly, AO, we are isolating AO and we succeeded at that. So AO is left on its own is equal to H over tan of 25. So AO now is my subject and it is written in terms of H. And that's the answer for the first part or for A in this question. Let's move to, so we found AO is equal to H over tan of 25. Let's move to the second part of the question, which is finding BO. So BO or OB side, BO or OB is unknown. Accordingly, we're going to use triangle POB, or we can name it BOP, to work out the length of OB in terms of H. And that's the sketch. So what's given to us is this angle, which is 33. Based on the given angle, H is the opposite side. So this is my 90 degree for sure because PO is vertical on the plane. So it's vertical on OA and it is vertical on OB as well. So this is the opposite side to angle 33 and OB is the adjacent side. Once again, we're going to use here the tan rule. So tan of 33 is equal to opposite over adjacent. Let's substitute in this rule. Opposite is equal to H, the adjacent is equal to BO. So tan of 33 is equal to H over BO. We're solving for BO, meaning we want to make BO the subject. So we're going to get rid of the denominator by multiplying all by BO. Accordingly, the result will be BO times tan of 33 is equal to H. In this case, H is my subject, but what do I want? Here, I want BO to be my subject. So accordingly, BO times tan of 33. To get rid of tan of 33, we're going to apply opposite operations. Opposite operation to multiply by is divide by tan of 33. So we're going to divide all by tan of 33 and accordingly BO is equal to H over tan of 33. So we found BO in terms of H, AO in terms of H, and BO in terms of H is H over tan of 33 degrees. And this is the answer for the second part of this question. The final part of this question is finding the height of PO, of the pole of PO. In order to do so, we are going, I'm not going to draw another sketch here because I don't have much of space. So we're going to use the triangle that is sitting on the floor, which is AOB, or we can name it BOA. So I'm going to, so this is the AO, which we found it in terms of H, and this is the BO, which we found it in terms of H as well. And let's highlight the triangle that is sitting on the floor. And the 60 meter here is my hypotenuse because it is right across the 90 degree angle. Accordingly, in this case, we are going to use the Pythagorean theorem, which states that hypotenuse to the power of 2 is equal to the horizontal side to the power of 2 plus the vertical side to the power of 2. And we said that normally the horizontal side is the one that is parallel to the x-axis, and this one which is the y-axis. So once we specify the hypotenuse, the other two sides one of them can be the horizontal and the other one can be the vertical. Let's substitute in this rule. The hypotenuse is 60, so here it's going to be 60 to the power of 2. If we assume that the horizontal is AO, so AO is h over tan of 25 all to the power of 2 plus the vertical side is BO squared, so BO is equal to h over tan of 33 all to the power of 2 as following. So 60 to the power of 2 is equal to h over tan of 25 to the power of 2 plus h over tan of 33 to the power of 2. Now, let's rewrite it. So it's 60 to the power of 2, which is equal to h to the power of 2 over, and this is how you insert it in the calculator, tan of 25 all to the power of 2 plus h squared over tan of 33 to the power of 2. And another way to write it, just so that you are familiar of how to write it, 60 to the power of 2 is equal to h squared over tan squared of 25 plus h squared over tan squared of 33. So if you insert this in the calculator, or if we simplify this further, 60 to the power of 2, it means 60 times 60, which is going to be 3,600, is equal to h to the power of 2 over, if you insert the squared button in your calculator, which is x squared, put two brackets. Inside the bracket, write tan of 25, and then put equal. You're going to end up with 0.217. And if you insert the squared button, which is x squared, and you put brackets, inside the bracket, put tan of 33, then put the equal, you will find the tan of 33 to the power of 2, which means tan of 33 times tan of 33. It's going to be 0.422. Now, when we are adding two fractions, the secret is, remember when we used to work with numbers, or when we used to work with fractional expressions, the secret of adding two fractions is having the denominator the same. So we're going to multiply, as for example, here, let me remind you about this. If we're saying h squared plus h squared over 2 plus h squared over 3, you're going to multiply the first fraction by 3 and the second fraction by 2, as following. So 3 times h squared is 3h squared, and then it's 3 times 2. The second fraction, we multiply it by 2, so 2 times h squared, it's 2h squared over 2 times 3. To simplify this, we're going to keep the common denominator the same, and we're just going to add the numerators. So 3h squared plus 2h squared is 5h squared over 6. If we apply the exact same thing here, so the first fraction, we're going to multiply it by 0.422. And the second fraction, we're going to multiply it by 0.217. And the common denominator is multiplying the two denominators by each other. So 0.217 times 0.422. So we're going to end up with this. And if we simplify this, you're going to add now 0.422 plus 0.217. So when we simplify it, the coefficient here, it's going to be 0.639 of, or times h squared over 0.0917. Now, we are solving for h squared. So we're gonna get rid of the denominator by multiplying all by 0.017 as following. So the denominator is gone from the right side of the equation, and here it's gonna be 3,600 times 0.0917. Now, we're going to get rid of the coefficient of h squared. We're solving for h squared. So we're going to get rid of the coefficient by dividing all by 0.63917. By dividing all by the coefficient. Get rid of the coefficient. So, when we get rid of the coefficient, h squared is going to be 3,600 times 0.0917 over 0.639. Now, again, we are solving for h, not for h squared. So we must square root each side of the equation to find h. Accordingly, the 1h is equal to 3,600 times 0.0917 over 0.6391, all under the square root. If you insert, this is ready to be inserted in the calculator, and if you insert it, you're going to find h as 22.7 meter, and this answer is correct to 3 significant figures. This was a long question. I recommend that you watch it a couple of times and you try to solve it on your own a couple of times. And if you struggle, please watch it again. If you struggle with any of the steps, if you struggle with solving it on your own without referring to this video, then you have to watch this video once again. Thank you so much for watching. Kindly like, share, and subscribe, and I will see you